Take out your highlighter because we're going to do some highlighting on the next page. So this is the top of page 277. And the first thing we're going to highlight is what does changing the Q do? And we find out that changing the Q just moves the graph up and down. So here we have x squared plus 2. It took the original graph and moved it up 2. Here we have x squared minus 3. It took the original parabola and just moved everything down 3. The pattern of the over 1, up 1, over 1, up 3 still happens. Over 1, up 1, over 1, up 3, over 1, up 5, over 1, up 5. That pattern still happens. All of that's happened is the graph has been moved down 3. So in your activity yesterday, we would say that these two graphs are congruent, the same shape as x squared. Because all that's happened is the graph has been moved down. Next, we look at inside. So take out your highlighter, the effect of changing the p-value. And this moves things left and right. But it's opposite of what you think, because you see a -2 sign, I tell you, you're going to think left because you see the negative. But everything inside is the opposite. So the x minus 2, it moves 2 to the right because now it takes a positive 2 to make your y equal to 0. And here with the x plus 3, it now takes a negative 3 for x to make your y equal to 0. So that's the reason it's the opposite sign, because you're actually thinking, what is the x value I have to plug in to make me get 0? And that would always be the opposite side. So now the q value moves it up and down, the p value moves it left and right, and together with the p and the q value, you always have a way to find your vertex. And if you look at the pattern, over 1, up 1, over 1, up 3, over 1, up 5, over 1, up 1, over 1, up 3, over 1, up 5, that pattern still stays the same when you move it left and right. And finally, one more thing to highlight. If we look at the a value, maybe I'll take a different color just for this word. We call this a vertical stretch or a vertical compression. Sometimes this is the proper terminology, but you'll also hear of this using this word. I guess I need a y equals here. This one's narrower than y equals x squared, and this is wider than y equals x squared. So notice in your original graph, scale's a little bit funny here, but here's over 1, up 1, over 1, up 3, over 1, up 5. 1, 3, 5. That's your normal parabola. Now, switching colors, we notice that if you doubled it, here we have a 2x squared, you now go over 1, up 2, then over 1, up 6, then over 1, up 10. So the 1, 3, 5 pattern got doubled. Same thing's going to happen here. Go back to my original one in blue again. Over 1, up 1, over 1, up 3, over 1, up 5. 5, 3, 1. But now, on the other one, I go over 1, up a half. Then over 1, up 3 halves. Then over 1, up 5 halves. So the 135 is multiplied by the half. Whatever your a value is, will affect if your graph gets narrower or wider than y equals x squared. And if your a value is negative, it flips your graph over and it opens down. That's something we've seen already. The a value is negative, that would flip it over. So if you had a -2, right? My normal one goes over 1, up 1, over 1, up 3, over 1, up 5. Now that I have a -2, I go over 1, down 2, over 1, down 6, over 1, down 10. So the 1, 3, 5 pattern still stays there, just the negative flips it over, and you know that it's opening down instead of opening up. So finally, if we have what is called the standard form, this is on your formula sheet as well. The standard form is right here. This is a very helpful form, because if you have the standard form, you know your vertex. You know that your axis of symmetry always goes through the x-coordinate of your vertex. And then you can use your a value to tell you if it opens up or opens down, and whether it gets wider or narrower than y equals x squared. And with that, you are now experts in graphing parabolas. Sort of experts. We're getting there. So example 1. We think of this as the standard form of our parabola. Looking at the graph, can you tell me where the vertex is? Well, I could go to my graph. The vertex looks like it's at 4, comma, you gotta be careful here because they're going by 2's. 4, comma, -2. So because it's 4, comma, -2, I would already know, I'm gonna leave some spaces here, it would be x minus 4, and then -2. Always the opposite sign inside the brackets there. Now for your a value, there's 2 different ways that you can solve your a value. One, you can look for the pattern, which is sometimes helpful. If I go over 1, how much do I have to go down to hit that? Does it look like I go over 1, down 3? Does that work if I go to the next one? I go over 1, down from 5 to 14 would be down 9. Can you see based on that the a would have to be -3 on the pattern? That's method 1. You just see it from your graph. Or you can actually, after solving and putting in the p and the q, because the vertex is easy to see, again, make sure I write it down correctly. There we go. I can also then take a point. So for example, this point right here is at 2, comma, -14, which mathematically says in your equation, and this is very important because this comes up over and over again. If you know a point on your graph, it makes your equation true. I can plug in -14 for y, and I can plug in 2 for x. If I solve this, I can add my like terms, so add 2 to this side, that'll give me -12 equals a. 2 minus 4 is -2, -2 squared would be 4. Divide both sides by 4, and I could solve that a is equal to 3. And sometimes you'll need to do this because what happens if the a value was something like 7/13? I guarantee you couldn't see it from the graph. It'd be like, ooh, you'd be guessing because you don't know where the graph hits perfectly. This one, I was a little bit, I didn't know for sure it was 3. I was guessing, but then when I went down to here and saw 9, I kind of felt that it was right. So using the pattern is a good strategy to find it quickly, but it doesn't always work, especially if the A value turned out to be a fraction. You wouldn't be able to guess where it was. So then you would need this technique of solving for A. And the technique is plug in a value that you know on your graph other than the vertex, and then you could solve for A. Okay, questions that you can circle on this one are 3, 4, 5, and 7.